What we're going to be talking about is the Rover Kit, as I mentioned before, but we're going to be covering kind of the basics. So we'll take a look at what is the Rover Kit, what does it look like, all of that. We're going to do a dive into the Rover Kit parts. So when you order this kit, we'll make sure that you understand every single part that comes with it. And just like any of our other educational courses, we do have a fully online course available. And this one actually also comes with some standards. The CSTA K-12 standards have been mapped to this kit, which is quite nice. So we'll talk about that. And we'll talk about some of the extra content that you can do with the Rover. Starting out with what is the Rover Kit. The idea with this is that even if you have, say, a computer science classroom or a classroom where you're not really heavily involved in electronics, you can actually still get that Rover experience without having to go too in depth with the electronics or all the circuit design. As we've seen with other kits, so just like any of our other kits, this is supported with Windows, Mac OS, and the Raspberry Pi. And of course, Python, Java, C# and Swift are also supported. So essentially, again, it's a Rover Kit. You're not having to do a bunch of the electronics, and you can actually program against it in a higher level language. So you're taking this thing out of the box, which we'll see later. You're essentially putting it on your desk, and then you're opening up your Java program, your Python program, and you're able to write code right from your computer to the Rover. So it's quite nice. So taking a look at what actually comes included in the Rover Kit, here's the main overview, and then we're going to be talking about each kind of main part afterwards. So taking a look at the main part here, we have the chassis. So the chassis actually comes with the battery pre-attached to it. So that's kind of nice. It's a single unit. It comes in the box like this. So this is what the box looks like here. Essentially, when you open this up, you just pull the chassis out of it, and it has the battery attached to it, which is quite nice, especially for computer science classes where you might not necessarily have all of the tools or the space to kind of put something like this together. Taking a look at the sensors here, we're going to go through all of them in depth, but we have a wireless hub, we have a thumbstick fidget, we have a motor controller, and we have a distance sensor. So those are the kind of core components of this Rover Kit. And as usual, we have all of the cables and all of the wires and accessories available. So taking a look at the main components here, we'll start off with the wireless bint hub. So the hub looks something like this, the normal hub. So this is the normal bint hub that comes in your getting started kit. And essentially the wireless bint hub is just a wireless version of that. So this will allow you to have your Rover on the ground and away from your computer, and you're still able to control it. So it's a really nice device. And another cool thing about this device is that once you've completed the Rover task or the Rover project, you can then take off the wireless bint hub and use it in a totally different application, which is quite nice. So that's kind of the main part of this kit is this wireless hub. Taking a look at the next kit or the next part, we have the DC motor fidget. So for education, we haven't done too much on our motor controllers. So Phidgets actually has a pretty wide range of motor controllers. So DC motors, brushless DC motors, servo controllers, stepper controllers. But for education, we haven't done too much with motors yet. So you can expect to see more in the future, but this one specifically is what we're using for the Rover Kit. So essentially what this allows you to do, this connects directly to your Vint hub. And essentially it just has two inputs here. So you can control two different motors from your program, which is quite nice. So essentially you have a power supply, and you're able to control on each output how much power is output, and so that allows you to control the speed of the wheels, and you can also control the polarity. So if you want your Rover to go backwards or forwards, you can do that all with this device. So quite a nice little device. The sonar fidget is used in this project as a object detection device. So here's my Rover here that I have built up. So you can see that sonar is right on the front of it, and essentially students are using that to detect an object and avoid it. That's the goal. If you have seen I'll just jump quickly to our real world examples page. So if you've seen this real world examples page, I'll put it in the chat here in case you want to take a look. We do have a company called Reckon Point that we interviewed, and Reckon Point basically designs robots, so very similar to this, but just a much more advanced version. And they actually have we have the video here. They showed their, Gabe is the CEO and founder there, but at the end of this video, they showed their robot off. And let's see if we can, let's see if we can see. So essentially they use that sonar fidget that we're talking about. So boom, right there. Hopefully you can see that okay. But they essentially have I think they have 4 sonar fidgets on their massive robot. So they have this big robot here, and let's see if we can find another section where it's showing. So this is their big robot. They have mechanism wheels down here. So obviously much more intense than the rover, but you can see they're actually still using the same, they're using the sonar fidget here for that same object detection, which is pretty cool. So that is one of the other sensors that's included in the rover kit. And then the last sensor that's included is the thumbstick fidget. So the thumbstick fidget, if you haven't seen it, looks like this, and it's essentially a joystick. So it allows you to put user input into your program. So essentially when students start out with the rover kit, they're going to be controlling it just in their code. So moving forward, backwards, avoiding collisions. And then one of the later sections, they're using the thumbstick to directly command the rover, which is pretty cool. So those are the main components. And then if we just take a look again, so essentially you're receiving the chassis with the battery built in. You're receiving those 4 components here. So the hub that's wireless, the thumbstick fidget, the DC motor fidget, and the sonar fidget. Another thing that you also get as part of the kit is a wireless USB adapter. So it looks like that. And essentially, if you have a computer that does not have Wi-Fi, students can just plug that into USB, and that'll give them the ability to connect to the rover. And again, of course, you get a battery charger, and you get all the required accessories. So after kind of getting an idea of what the rover is, we'll now take a look at the online course. So again, as usual, we have a fully online course available for students. So I'm going to go to that now, and I'll put that in the chat as well. So that is the link to the online course. So this course basically has 2 parts. So we have the main part here, which is the kind of the introduction. So if you just received your rover kit and you're just starting, you're going to start at section 1 here, and then you'll work your way through 1, 2, and 3. And then we also have some extensions. So the extensions are using hardware that is not included in the rover kit. So we'll talk about that in a little bit. How you actually get to this page, I'll just go back to our main kind of website here and just show you how to navigate to it. If you don't have the link, so you'll go to this Learn tab up here, and then you'll go down to Projects here. And that's where you'll find the rover kit. So we can see it right there, the Phidgets Rover Kit. And you could also filter it from this little menu down here. So if you hold Shift and click on that, it will filter out the rover kit project. So essentially that's how we get to this page. And then the first step of this page is number 1, the Phidgets Rover Kit. So we'll click through to that and we'll be brought to this page here. So this is the introductory page. This will kind of look and feel just like the Getting Started Kit. Essentially you have the navigation on the left-hand side here, and you have the kind of goals for the first one. So for the first section here, the idea is to learn how to use the wireless Phint hub, to learn how to use the DC motor controller to actually control the wheels, and to use the sonar fidget. So there's kind of 3 tasks that are part of this. So as usual, we're going to use the navigation on the bottom of the course to kind of work our way through. So I'm going to hit next, and it'll bring us to the parts section. So here is our parts section here, and we've talked about all of these already. So I'm going to skip through this, and I'll go to the assembly instructions. And we'll see here that when you first get the kit, it all comes kind of pre-assembled. So this is exactly what it looks like when you get it. So you just have the plain chassis, and then on the underside, you're going to have the battery that's attached. So essentially, they're just pulling it out, and they have the full kind of assembly ready to go. And all they have to do in the assembly steps is essentially just put on some dual lock to adhere their Phidgets to the chassis. So we can see that here we have, place a piece of dual lock on the chassis here. So they're putting dual lock on there, and they're putting the dual lock on their sensors. So this is the controller, actually, the DC motor controller. And then they're just placing it on the rover. So pretty straightforward. There's a little bit of wiring in this project compared to other projects. So here they are going to be wiring the DC motor pairs to the DC motor Phidget, but pretty straightforward. And at the end of it, they kind of have all of their sensors and their Wi-Fi hub attached, and they'll have something that looks like that. So they have their Wi-Fi hub on the back there. They have their DC motor Phidget, and they have their sonar Phidget. And then the last step is to connect their battery to their little harness. So they have a wiring harness that routes power to all the devices. So pretty straightforward. Things to note on this step, there's not too much. The only thing I would say is at the end of the class, make sure that they are disconnecting their batteries. And when you order classroom sets of these, it comes with a little charging hub. So you want to make sure that at the end of every class, they're kind of disconnecting they're disconnecting from power, they're plugging it into charge, so that when they come next class, it's ready to go. And just like any other project with Phidgets, so none of the code is actually living on the device itself or on the rover or on the Wi-Fi hub, anything like that. So if you have a student using this in first period, you can give it to someone in second, third, fourth period, and it'll have no effect on that person. So you can share the robot without any fear of code being overwritten or anything like that. So after they get the rover all built up, the next step is to connect to it via Wi-Fi. So for this section, I'm just going to quickly modify okay, here we go. So I'm just going to share my other screen here so that we can see how this works. So essentially they're using the Wi-Fi adapter that we saw here. And if they do have Wi-Fi built into their computer, that's fine. They'll be using that, of course. But let's see here. I'm going to share this screen here. There we go. And I'll move this over. Perfect. So essentially in this step, when they plug in their rover, they're going to have a red LED that is lighting up on the back of it. So let's see how you can see that. There it is there. So you have a red LED that's lit up, and that indicates that the rover is connected to power and is booted, or I should say the Wi-Fi hub is connected to power and is booted. And then from there, what they're doing is they're going to go to their network tab, and they're going to find the network. So here it'll always show up as Phidgets _ hub 5000 _ a number. So we'll go back to the course and show you where that comes from. But essentially, they're going to connect to this. The password is shown in the course. I'll show you that in a second. But one little tip here is that when you do connect, if you're on a Windows machine, Windows seems to have a really long animation for connecting. But if you bring it right back up, it connects really quickly. So just a little tip that we've seen before in classrooms is it doesn't actually take that long to connect, but for some reason, Windows has a really long animation for that. So all the steps I mentioned are in the course as usual. Basically on your Wi-Fi hub is where you'll find that information. So the Wi-Fi password is printed on the hub, and the network name, those last 4 or 5 digits, or 6, I guess, are printed on the hub as well. So that's how each individual student will be able to kind of figure out which hub is theirs and which Wi-Fi network they should be connecting to. So again, after they connect, it's going to say no internet secured on a Windows machine. And essentially that is because you're making a direct connection to this device, which is not an internet connected device. You're just making basically a direct connection over Wi-Fi. So that's expected. So after they connect their device over Wi-Fi, the next step is to actually start writing some code against the device. So again, very similar look and feel to what we've seen in the Getting Started kit. They have the GIF here showing what they can expect from this step. So they'll have to create a project as they've done before. And essentially, as they're used to, they have a little bit of code to get them started. So I'm going to copy this code into Thonny. So Thonny is a development environment for Python, which we use quite a lot just simply because it's really nice and simple. It's a nice one to use if you're just getting started with Python, and it's pretty nice for these examples, which is why I like using it. But essentially, just taking a look at the code. So the prerequisite for the Rover kit is going to be the getting started kit. So I would definitely heavily recommend that you run them through this before doing the Rover kit. And if they've been through that getting started kit, this will be a breeze. So there's not too many different things here. The only thing to note, they're importing their Phidget libraries just like normal. They're importing their device class just like normal. Here we're using the DC motor for this step. The only difference here is that we're now using this net library, so Phidget22.net, and essentially that is how we connect to the Wi-Fi hub. So you can see this line here. This is something that you probably have not seen before. So it's saying net.add server, and it's specifying an IP address. So essentially, anytime they want to connect to their wireless hub, they're going to have this line at the top. And that will just make sure that, okay, I'm now using that hub, that's that wireless hub. So that's the only kind of thing that will be slightly different in their code. Other than that, it's going to have the exact same look and feel as all of their other projects. So for example, they're going to be creating their objects. So here, they're creating 2 DC motor objects. And again, that is because the DC motor Phidget has 2 channels. So we talked about this DC motor Phidget and how it had 2 channels. So essentially each channel is going to be an object. So they're creating their left motors for the object that's controlling the left set of motors, and the right motors to control the right set of motors. Because there is 2 of the same object on the board, they set the channels. So this is something that is used. You may not have seen this if you've just done the getting started kit, but essentially if you have 2 of the same objects on the same device, that's where you differentiate between them with channels. So that's why this code is here. And then after that, they're just simply opening the device. So they're opening their left motors, they're opening the right motors. And then when they are both open and ready to be used, they are setting a target velocity. So essentially setting a velocity is saying how much power you want to provide to the motors. So the range here is from -1 to 1. So -1 would give me the opposite direction. So if 1 gives me forward, -1 will give me backwards. 0.5 will give me half speed, and you can go, as you can basically, 0.1 would give me 1/10 of my full speed. So that's how the target velocity works. Pretty straightforward. And essentially they're turning both motors on full speed. They're waiting 1 second, and then they're stopping the motor, and that should give them that look that we saw here, which is the motor driving forward for 1 second and then stopping. So if we run this code here, we should see the wheels spin. So I'll run this. And then we can see the wheels spin there. So that's their first step, is just basically getting used to the new code and moving the rover a little bit. As they scroll down, they can see there's a section here called Did Your Rover Spin? So depending on the way that they wire the rover, instead of getting a forward back motion, they may get a spinning motion. And essentially what that means is that one of their wires on their DC motor just needs to be flipped. If the rover moved backwards instead of forwards, essentially again, so DC motors, you apply voltage, they spin in one direction. If you reverse the voltage, they spin in the other direction. And basically they can solve their rover moving backwards by either swapping both sets of wires, or just in software by saying, hey, my rover, I wired it up a certain way. So to go forward, -1 is the forward direction for me. So pretty straightforward. And probably a nice way, if you are more of a technical class, you could talk about why that is, and you could talk a little bit about DC motors. So it's a good little option there. And again, just like we've always had, there's practice sections here, so that they can practice and go back in their code and modify. So that's what the flow of this course looks like. So you have the GIF, you have the code, and they're investigating each section. So that was moving forwards and backwards. The next section is turning. So they're going to learn how to actually turn the rover. And basically, because it is this tank steering, in order to turn the rover, they're going to have one set of wheels going one direction while the other set goes the other direction, and that will provide that turning motion. So again, they'll have the code here that shows them that. You can see the main part here is that you have one set of rovers going forward, or of wheels going forward, and one going backwards, which gives you a turning effect. After that, they're going to jump into avoiding obstacles. So avoiding obstacles is done with the sonar fidget, as we saw before. So essentially, they have that sonar fidget on the top, and their code is going to be looking at that data. So I'll run this quickly. So if we take a look at this, see here. So we can see that my wheels are spinning, and on my screen here, I'm getting a distance value. So as I approach the sonar fidget, that distance value drops. And then if I go really close, my wheels stop. And if I move it away, you can see my wheels turning again. So it's all in the code here, but essentially what they're doing is they're just taking a look at the distance value that's reported from the sonar. And then they have a value that they're specifying. So here, if it's less than 200, they're going to stop their motors. And if it's not, they're going to go forward at a slow speed. So pretty fun little exercise there. And again, they can try modifying things. So, modify the speed and the object detection to see how their rover can work better, which is pretty fun. So that is that. And in the end, they end this first section with a challenge. And the challenge basically just puts together everything they've learned in this section. And we try to get them to basically create a square with your rover. So create a little piece of code that moves your rover in a square fashion. So that is that first rover project section. Let's go finish, and we'll go here. So I won't jump into all of these because we don't have time today. But essentially, after they finish this, they start tweaking their rover and making it a lot better. So in this section here, they're going to learn about acceleration. So the DC motor fidget has a property called acceleration. And essentially what that does is it tells, it specifies how fast the wheels can change. So maybe I'll just quickly run this because this is kind of it's a little bit hard to explain to students if you haven't seen it. So I'll just quickly take a look at this. So essentially, if I have a piece of code here, and if what we're doing is we're opening the motors and then we're setting a target velocity. So by default, there's a default acceleration built into the motor controller that will kind of slowly ramp up to the target velocity, which can be quite useful in a lot of different applications for DC motors. But actually for rovers, what you want is you want the velocity to change almost instantly, because that will give you a very responsive rover. So if we take a look at this section here where we talk about high acceleration, I'm just going to put this in here so we can see it. Basically, the solution here is to modify the acceleration of the motors after opening. So you open them, you increase the acceleration, and then you start using them. And essentially what that will do is if you change from 0 to 1, it will change basically instantly, which means your rover will be quite responsive, which is quite nice. So that is that section there, acceleration. And then in the last section, they learn how to use the thumbstick to control the rover. And the only thing I really want to mention about this section here is that you actually need to use your Vint hub. So there's a section here in setup, I believe. We've seen a lot of schools where they're connecting their thumbstick directly to their Wi-Fi hub. So they have a cable coming from here to here, and they're controlling it like that. The actual way you should be doing this is by connecting a different hub. So the hub from your Getting Started kit, you should be connecting that to your computer, your main PC, and then you can control your rover from your desk while it's on the ground doing its thing. So that's the only thing to really note there. And that's actually the learning how to use the thumbstick and how to read the data is actually a pretty fun task for students. So it's a lot of fun when they start using the thumbstick and they can see how it responds. So that's definitely a fun part. And the extensions. So as I mentioned before, these include sensors that are not in the rover kit. So if you have a classroom bundle, for example, you'll have an accelerometer and you'll have a light sensor. So these are essentially using different things to control the rover. So the accelerometer, for example, depending on how students tilt it, they're going to be sending commands to the rover. So they could have it in a little box or something, and they could just use movement to control the rover, which is quite fun. And then they have a light tracking rover. So this is something that will take a look at how much light is in the room and try to navigate to the nearest light source. So there's a bunch of different extensions that you could do with a rover. Those are two that we include. So that is kind of the basic breakdown of the rover kit. We only scheduled half an hour for today, so we just kind of wanted to go over all of the basics. I guess the one thing to say too is we recently added a bundle for the rover kits. So by default, the price is $55 for the whole kit, which is actually quite nice. And now there's actually quantity discounts. So you can see 12 or 24, and the price is even reduced further. I think the lowest price is about $45 a kit. It might be a little bit less, but you actually get quite a lot of classroom time spent on this, and you get quite a lot of hardware for only $55 US, which is quite nice. So I'm going to stick around here for any questions that you may have. But as usual, we do appreciate everybody stopping by and taking the time to learn a little bit more about your Phidgets projects. If you have any questions, please feel free to email us at education@phidgets.com. We appreciate you guys stopping by.